The specific rotation for R plus glyceraldehyde is plus 8.7. So the plus is related to this plus. So you'd have to measure it to know that it's rotating light in the positive direction. And then it asks you, what is the specific rotation of S minus glyceraldehyde? So if we know that the R enantiomer is positive, the S enantiomer is going to have to rotate light in the opposite direction. So this is that key piece of information that we need for this question. We need to know that enantiomers rotate light equally and in opposite directions. So that's the information that we need here. And we should be specific what sort of light. This is light that's all oscillating in one plane, so it's all going in the same direction, so we call that plane polarized light. So it's all going in one direction, and when that light hits a solution that contains a chiral molecule, it's either going to rotate positive or negative. So if we know that the plus glyceraldehyde rotates light plus 8.7, its enantiomer must be rotating it equally and in the opposite direction, so it's going to have to be negative 8.7. Okay? And so what would happen, just to put a little bit more additional information, is that if you had a racemic mixture, let's consider this, if we had a racemic mixture of the enantiomers, so a racemic mixture refers to a 50-50 mix of enantiomers. So that means that half of your molecules in solution will be wanting to rotate light one way, the other half would be wanting to rotate it equally in the opposite direction, and then they would cancel out. And that's when you get 0, right? So you would have a 0 degrees for that. So this isn't actually related to the first problem, but this is something that is important to be aware of. And it comes about because of the fact that enantiomers rotate light equally in opposite directions.